Hey everyone, and welcome back to our channel. In today's video, we're going to be finding out the maximized area of a square hole in a grid. Now you will be given two integers, n and n, and these two integer arrays, h bars and v bars. The grid has n plus 2 horizontal and n plus 2 vertical bars, creating 1 into 1 unit cells. The bars are indexed starting from 1. So I'm going to show you what that means. For example, let's take the grid has n plus 2 horizontal and n plus 2 vertical. For example, let's take 2 horizontal bars and 2 vertical bars. Now these will create a 1 into 1 unit cell. You can see 1 into 1 unit cell. Okay? The bars are indexed starting from 1. So over here we got 2 horizontal bars, so it's 1 and horizontal bars and 2 vertical bars, 1 and 2. Alright, so this is the bare minimum you can get, the bare minimum, when n is equal to 0, and when m is equal to 0, you get 1 cell, creating a 1 into 1 unit cells. It just depends on your n and m values, and the bars or index starting from 1. So when I say there is n plus 2 horizontal and n plus 2 vertical bars, I mean bars, not cells. So the 2 vertical and 2 horizontal bars together create 1 cell. Now you need to remember that. They don't represent the cells, they represent the edges, the bars. You can remove some of the bars in H bar from horizontal bars and some of the bars in V bars from vertical bars. Note that the other bars are fixed and cannot be removed. That means the ones that are given in the array can be removed. For example, they have given 1, 2 in H bar, means that you can remove the first bar and the second bar, but you cannot remove the other bars that are not mentioned in the array, and they remain fixed. Now we're going to return an integer denoting the maximum area of the square-shaped hole in the grid after removing some bars, okay? Or possibly none, okay? So over here we've got some more examples. We'll go through them. And this is the input. We've got n is equal to 2, m is equal to 1. Now your n is going to be representing the horizontal bars, and m is going to be representing the vertical bars. So you got 3 horizontal bars and not 3, I'm sorry, 4 horizontal bars and 3 vertical bars. So you got 4 horizontal and 3 vertical bars. Okay. So I'm going to be drawing first the vertical bars. So let me go ahead and draw 3 vertical bars, and let me draw 4 horizontal bars. So 1, 2, 3, and 4. So this is how your initial bar setup is going to look. Now you can remove the second bar and the third bar, and in your vertical bar you can only remove the second bar. 1, 2, and 3. You can remove the second bar, and here you can remove the 2 and 3 bars. Whenever you're removing the bars, make sure that you need to remove the bars such that it's going to form the largest hole, and that hole should be in the shape of a square. Okay, the largest possible hole that you can form in the shape of a square by removing some of the bars that are mentioned over here. We can only remove the bars that are given in the input array. Removing a bar will merge the adjacent cells. For example, over here, I'm going to remove one of the bar here. So let me remove the second bar, and you can see the amount of space that we're getting in. As we know that each cell is 1 unit. This is 1 unit, okay? And this is also 1 unit, right? So I'm gonna go ahead and let me just quickly remove this. Now, how much unit do we have over here? We have 2 units of height. So I did remove the second bar. Now we got here 2 units. But can you guess what is the area? It does look like a rectangle, right? So we got a height of 2 and the width is just 1 because this is 1 unit and both of these together. So 2 into 1, it is not a square, okay? It is not a square. Now, the one thing that you can note over here is that when we are removing a bar, it merges the nearby cell, okay, and it creates a gap. Now, there is a formula to calculate this gap. For example, I'm removing the second bar and I'm removing the third bar. Can you guess how much it is? 1, 1, 1, 1, 4. How do we calculate this? It's very simple. Let me teach you how. We're going to count the bars removed, okay, plus 1 to calculate the gap. Let me teach you. So we got here 2 bars, okay, and we got here 1, 1, and 1. These are the units that we got. Now I'm going to remove the bars, okay. I'm going to remove the bars and you can see that 3 units. Now the bars removed are 2 plus 1, I will get 3. Okay, 3 is the amount of gap I'm getting when I'm removing the bars. In conclusion, so finding out the gap is actually very simple over here. You need to count the bars, the consecutive bars that are removed, and you need to do plus 1 to find the gap. Okay, it's as simple as that. Now let me try removing the second bar over here, and you have a gap of 1 and 1 here. Okay, but this doesn't really form a square, right? Let's not remove one of them. Let's have the 3 there. Let's not remove it. And now you can see there is a square forming. There is a square forming here. All right. So this is the largest squares that is formed over here. 1 and 1 equal 2. Okay. 2 and 1 and 1 over here we got 2. 2 into 2 we got 4. Okay. We got the maximum area as 4. Simple, right? Now in this image, we got here 3 horizontal bars and 3 vertical bars. And we got here horizontal bar to be 2 and the vertical bar to be 2. These 2 are completely removed to form a square of area 4. Right? It's 1, 1, 1, and 1. And if you want to calculate the sides, it's pretty simple. You just need to take the maximum. You just need to take the height and width of this. If you see over here, the maximum height and the maximum width of this is going to be 2 and 2. Okay, or you can simply say the maximum consecutive bars I can remove from the horizontal and the maximum consecutive bars I can remove from the vertical bars. the maximum you can remove, plus 1 creates a gap for you. Now, when you calculate the longest consecutive horizontal bars plus 1 and the longest consecutive vertical bars plus 1 can give you the both height and the width of your area that you want to calculate, the area of a square, right? Now, you need to remember that you do take the minimum of both of your height and the width. Let me tell you what. You can see over here, we got 2 and 3, and vertical bars are 2 and 4. In this case, 2 and 3 are consecutive, so we do remove them. Let me up here that. Yeah. So over here, we remove this 2. We also remove this 3. But in vertical bars, you need to remember that they are not consecutive. So you do have to remove either one of them, or even if you remove 2, you will not achieve the largest or maximum area of the square. So to do this, what we actually do here is we take the length of the consecutive bars that you can do. So we've done 2 and 3, which will create a gap of 3. Okay, 3 is the maximum gap that you can get. But when you're removing the 2 or 4, you do not get that maximum gap. Let me help you visualize that. For example, over here, let's say when I try to remove this bar, okay, I remove this bar and then I remove this bar. When I remove both of these bars, I created a gap of 3. Now this is my horizontal bars. Okay, so I created a height of 3. Now when I wanted to remove my vertical bars, in this case the width, when I try to remove, for example, the second one over here, that does not create the maximum square. The reason is because you don't really create that, because you have 3, which is the largest, and 2 width. That is the maximum width that you can do. There is no way you can surpass that width. That is the minimum width that you can get, and 3 is the maximum height you can go, and 2 is the maximum width that you can take your square. Now in this case, when I have to choose which one to reduce, I try to reduce my height here. So what I do is take the minimum of both of them so that I can get equal size. So over here, I can do reduce my 3 to 2. So 2 height and 2 width is taken so that I can get an area of 4, which is the maximum area I can build off. Now, now you do need to remember that there are multiple ways for you to attain this. You can either remove 2 or you can either remove 4 in this case, or you can either remove you can either remove the second vertical bar, or you can also remove either the fourth vertical bar. Coming on to the horizontal bars, you can either remove the second horizontal bar or third horizontal bar. Ultimately, the main concept that you need to take away from this problem is the height is the maximum consecutive bars removed from the horizontal plus 1, and width is the maximum consecutive bars removed vertical plus 1, and area is the minimum of this height and the width. And area, I don't mean area, I mean the side. Okay, so I mean the side. Side is the minimum height and the width of your square, and the area is equal to side into side. Okay. So I'm going to show you guys how to write this program. So the first thing what I'm going to do is I'm going to take the maximum horizontal bars I can get and the maximum vertical bars I can get. Okay. And after we get maximum horizontal and maximum vertical, we need to find the side. The side is going to be mat.minimum, and I'm going to have the minimum of maximum horizontal plus 1 and maximum vertical plus 1, because that is the formula for gap. Now, if you want to find the gap or how much gap you have for the height and the width, you need to do plus 1. And after that, you need to return side into side for the area. Now, to find out the consecutive for both height and the height and the maximum height and the maximum width, I'm going to be using just a function over here. So I'm going to have the longest consecutive. That's going to be the name of my function, and longest consecutive is going to be another function. Now inside of these, I'm going to be passing the h bar, and that is the horizontal bars and the vertical bars. That's what we need. Horizontal bars, as well as I'm going to be passing the vertical bars. Now I have written the function over here. I'm going to write, we are passing in an array. I'm going to name that array as bars. Okay, and we need to return a maximum horizontal and the maximum vertical, that is the maximum height and the maximum width. So that is why I've written int over here on the function. Next I'm going to do is I'm going to be sorting this bars. Why do I sort it? Because sometimes they're not in the sorted form, as we've seen in the examples. If they're not in the sorted forms, then it will be difficult for us to find the consecutive bars. For example, in this case, if for example it is like 4, 3, we actually do not know it's consecutive, because consecutive means 1, 2, 3, and 4. The before number must be one number less than the next number, but in this case it is not here like that. The first number seems to be more than the second number, but they are consecutive. So making this sorted helps us to find out the consecutive numbers. So that is the reason that we're sorting the bars first before proceeding anything. Next, I'm going to have two variables in this case. I'm going to be having the maximum variable initialized to 1 and the current variable also initialized to 1. Now we need to remember, whenever we're trying to find out the longest consecutive bars, you need to remember, even if there is no bars existing, you need to remember there is a minimum possible of longest sequence 1, not 0. Okay, there is a possibility of having 1. For example, let's say we have only one cell possible, then this states that there is a possibility of forming a square using the consecutive bars even if there is 1. So there is a minimum possibility of forming a longest consecutive bars. Okay, the reason I gave current is equal to 1 is because I am calculating a bar. First, I'm taking a bar and I'm considering it to be a sequence. Okay, I'm not stating that it's not in a sequence. I'm stating that the bar that I've currently taken is also considered to be in a sequence. Okay, that is why I've given current is equal to 1. Okay, now the next parts are fairly simple. They're fairly very easy to code up. I'm going to show you how. They're very easy to do. Now you do need to remember that you need to stop indexing from 1, because and less than bars. Length I plus plus. Now, in this case, if bars of I, okay, if bars of I is equal to bars of I minus 1, okay, plus 1, then that is a consecutive sequence. Then you do increment your current plus plus, ensuring that this bar is also included in that sequence, okay? Make sure you remember that you're not including I is equal to 0. That means you're not considering your previous bar, but you're considering it in your current. Current is equal to 1. Make sure that your previous bar is also included in your sequence. And when you do current plus plus, you state that there are 2 bars that are consecutive. Okay. Else, I will reset the bar to its older state. I'll say that from this sequence, I'm considering this bar as sequence. Okay. And then what I'm going to do, I'm going to say max equal to max. For each step, I will be calculating the maximum and the current. Okay. Making sure I keep updating, and then I will return the max. Okay. So for example, in this case, let's take our bars to be like this. Let's take 2, 4, 5. In this case, I am considering 2 to be one of my sequence, okay? I'm considering, so I'm having my current as 1 because I'm considering 2 to be a sequence. When I'm comparing 2 and 4, I came to know that they're not consecutive, so I'm keeping my current to be 1 still as well. Now, when I'm keeping my current as 1, you need to remember that I'm considering 4 as my sequence now. Now, when I go and check for 4 and 5, I do know that they are consecutive, making my current to go plus plus, making it 2. That means there are 2 consecutive bars.